Okay, so this is number 8 on 3.5 assignment. So graph each quadratic function. We just graphed f of x equals x squared, and g of x equals x squared minus 4 now. What's f of x equals x squared minus 4? Where's that going to move the graph? Say that again? Well, this is the function. F of x equals x squared minus 4. Where is that going to move the function? Down 4. So it's the same thing. This one, we got over 1 and up 1 from there, over 2 and up 4, and left 3 and up 9. Is that right? Oh, I'm over it too. Huh. So over 3, 1, 2, 3, and up 9. Whoops. Right there. And right over here. Okay, so I've got this one now. Okay, and then the last one says to graph x minus 1 squared minus 4. So f of x equals x minus 1 quantity squared minus 4. So then this one, how does that one move? From the green one, where does it move? Okay, it moves to the right one. So it's going to be right here. And every point's going to move to the right one. So you're going to get this shape right here. Okay, any questions on that? Okay. So you should know which way it shifts according to what's up here. F of x equals x minus 1 squared, subtract 4. So let's answer the next question. How do the functions compare to each other? Raise a hand. Just let's name a couple. Branson? They have the same scale? Okay, they're all the same what? The same shape. They're all the same shape, just in different areas. That's good, okay? That's about it, right? They're all the same exact shape parabola. They've just been shifted around. They've been moved. Same scale, however you want to say it. Okay? 3.5? Oh, yeah. You got to remember, on these homework assignments, this goes back and reviews things we've done before. So part 7A and 8A are review. Okay? Part C says, how do g of x and h of x compare to f of x? Oh, wait, these aren't all. The second one was g of x, didn't it? And the third one was h of x. I wrote them all as f of x. So let's rewrite those. So I have g of x, and I have f of x, or h of x. You guys? That part C says, how do g of x, h of x, and compare to, how do g of x and h of x compare to f of x? What would you say? They have the same what? So, okay, these two are g of x and h of x. But how do these two compare to that one? Okay, it's almost kind of like the same answer as last one, right? Same dilation. Yeah, that's one way you can put it. They have the same dilation. They have the same scale or factor. They're the same shape. They're just moved, right? How does g of x compare? Well, it's 4 down from, you can say that. G of x is 4 down from f of x. And h of x is 4 down and 1 to the right of f of x. Does that make sense? Part D. Look back at the functions above and identify the x-intercepts of g of x. What are they? What are the x-intercepts of g of x? Okay, so if I was to write them down, it would be negative 2 comma 0 and 2 comma 0, right? be my x-intercepts of g of x. It's the green one. Okay, then it says part E. What are the coordinates of the points corresponding to the x-intercepts in g of x in each of the other functions? So where are the points? Okay, so we got g of x as the green one. Everybody look up here so you can see what we're doing. Gx is the green one right here, and notice that it's over 2 and up 4. So let's compare f of x, the points that correspond to the two x-intercepts right here in g of x. What points is it in the red one right here? Say that again, Kyle. Say that again. No. Like, see, here's the x-intercepts, 2, 0, and negative 2, 0. Notice it's 2 over and 4 up. 2 to the left and 4 up, right? So in the red one, yeah, 2, 4 and negative 2, 4 is the answer to that. Got that? For f of x, what about h of x? Yeah, we're answering D right now, E. E is in everyone. Okay, how does h of x compare to g of x, compared to the x-intercepts of g of x? So we have 2, 0, negative 2, 0. Where are they on h of x? 3, 0, and negative 1, 0. Got that? So the blue one, all it did is shift it to the right. So it's just going to be 3, 0, and negative 1, 0. That's all it did. Part E says, what are the coordinates of the points corresponding to the x-intercepts in g of x and each of the other functions? So the x-intercepts were 2, 0, and negative 2, 0. Well, where are they on the other one? Yeah, the other ones are at 2, 4, negative 2, 4. So it was 4 up, right? So this one, going from this one to this one, it was 4 up, right? In other words, 2, 4, negative 2, 4. Whereas this one was 1 to the right. Well, you can look at the numbers. You can see why it's that way, how we horizontally and vertically shifted it. Okay, question number 9. How can the transformations that occur to the function f of x equals x squared be used to determine where the x-intercepts of the function's image will be? Remember, transformation is moving it. We did vertical shifts and horizontal shifts. So how can the transformations that occur in the function f of x equals x squared be used to determine where the x-intercepts of the function's image will be? How did we use it right here? How did we use this one right here? The x-intercepts were at 0, 2, and 2, 0. And what did we find out they did? Okay, it went up 4 because it's just, well, from x squared, it went down 4, right? Because it was the vertical shift. That's what it was talking about. You can just look at the horizontal and vertical shifts and tell. That's basically what it's asking. Look at the horizontal and vertical shifts, and you can tell by that. Okay, you're doing kind of the same thing on 7. So I'll let you guys do that one on your own. Okay, now on problems 10 through 15. I want to do one of those with you. Which one would you like to do? 10 through 15. What was that? You're going to do 15? Well, okay. What do you notice about 13, 14, 15 that are different than the first 3? Well, 11. Okay. 11, 13, 14, and 15. What do you know about all those? Jaden said it. He said they're all in vertex form. Remember vertex form, you guys? Okay, what form are the other 2 in? Standard form, right? Do you guys want to do one in standard form or vertex form? I'll do one of them with you. Choose one of the ones in vertex form. I'll do that one with you first. Well, it asks you to find says, use the given function to find the missing values. Check your work using a graph. Okay. Okay, so let's do number 11. You're given g of x, x minus 5 squared plus 2. Okay. So you're asked to first of all find g of what? Does that say g of 0? Yeah. You can do this in one of two ways. You can. I would just plug in 0. So that means I'm going to go 0 minus 5 squared plus 2. And I've got to simplify that. Whoops. Let's put that in the wrong form. 0 minus 5 squared. Well, if I'm following order of operation, what do I do first? 0 minus 5, right? Which is negative 5. And then I square it, and I get positive 25. And then I add 2 to it, and I get 27. Okay, so there's that one. The next one, g of 5. So I'm going to plug 5 in. So this one's a pretty easy one. 5 minus 5 is 0. Square 0, and you get 0 plus 2, and you get 2. You guys all understand that first one, the point 0, 27 is on the graph? And the second one is 5, 2 is on the graph? Do we understand that? Okay, the next one is asking you to find g of x equals 0. G of x equals 0. What is x equal? Well, if g of x is 0, here's g of x right here, right? So I'm going to plug 0. I'm going to replace g of x with 0 times x minus 5 squared plus 2. And I have to solve that for x, right? The nice thing about this one, you guys, we don't have to use a quadratic formula. Why don't we have to use a quadratic formula? Because it's in vertex form. When it's in vertex form, it makes it easy solving for x. What do I have to do to solve for x right here? Just get x by itself. What would I do first? Subtract 2. So I'm going to subtract 2 from both sides, and I'm going to get negative 2 equals x minus 5 squared. I can square root both sides. Uh-oh, I see a problem here. Yeah. Well, I just won't get a real number, right? By the way, when you take the square root of both sides, you get plus or minus on that one side. It still is easy. We don't really need these parentheses because we took the square root of both sides. And then what do? Add 5, and we'll be done with this problem, right? So I'm going to put the x on the left side. X equals 5 plus or minus. When I have the square root of a negative 2, you guys remember what the square root of a negative number is? It's an imaginary number. Have we gone over that in this class? 2i. Yeah, it's going to be I square root of 2. Did we go over that in this class? I'll tell you what, you guys, between my pre-calculus class, but you guys went over it last year. You should know imaginary numbers. Yeah, you went over it in math 2 because I'm doing it right now in my math. No, wait. This is math 2. I get so confused which class I'm in. Okay. So we haven't gone over i's yet, have we? All right. I is the imaginary unit. Yeah, hurry back. Okay. So the answer to that is plus or minus 2i. Did I write that problem down correctly? I did. Hey, by the way, it says check your answer with the graph. I want everybody to pull up your calculator right here. Go to your y equals. And we're looking for the x-intercept, right? If y is 0, we're looking for the x-intercept when y is 0. So what I'm going to do is I'm going to type this into the calculator. What was that equation again? It's parenthesis x minus 5 squared plus 2. I'm going to hit zoom 6 for a standard window. What's the x-intercept here? There is not one. It does not touch the x-axis, right? And that's why we get imaginary numbers for the solution, okay? So whenever the solution's imaginary, it's not actually an x-intercept because the graph doesn't cross it, but it's still a solution. We're going to talk about that why later on, okay? Just for right now, go with that one. If you come up with an imaginary solution in the future, I mean on any of these other problems, all I want you to do is write the answer like, all you guys needed to do is write the answer like this, 5 plus or minus the square root of negative 2. Just leave it as a square root of negative 2 because we haven't learned about imaginary numbers yet. Okay? You can put I squared of 2 if you want, if you know it. Okay? We'll be talking about those soon. In fact, I think... Huh? Well, yeah, I would write down there is no x-intercepts. Because an x-intercept and a solution to a solution to a quadratic equation are the same if it actually crosses the x-axis. If it's not, if it doesn't cross the x-axis, then they're not the same. Okay, we got one more part to that. What's the last part to that? We got to find g of x equals 16, right? G of x equals 16. What is x? So this time we're going to plug, what are we going to plug in where? What's going in where? This part's easy, guys. It tells you. G of x is going to go, 16 is going to go in for g of x. Where is g of x? Right here. For those of you guys that don't get this, you're just going to replace that with 16. That's all it means. This is not rocket science right here. This is 16 equals x minus 5 squared plus 2, right? Can I solve this one the same way I solved the last one? Square root it, and then add 5. Yeah. Yeah, that is. So minus 2. So we get 14 equals x minus 5 squared. Then I square root both sides, right? This time I have a positive number to square root, which is nice. I have the square root of 14. We're going to leave it like that. It's plus or minus now. So I'm going to get x minus 5 on this side, plus or minus the square root of 14 on this side. What's the last thing I got to do? Add 5. So my solution is going to be x equals what? 5 plus or minus the square root of 14. Now, can we figure out where approximately that is? Go 5 plus the square root of 14. What is it, you guys? 5 plus the square root of 14. Well, square root of 14 is going to be somewhere around between 3 and 4, right? What is it? Put it in your calculators, you guys. 5 plus the square root of 14. Just a second, you two. We're going to write these two down, and then I'll answer your question. What is it? 8.74. Now go 5 minus the square root of 14. What's your other answer? What? 1.2, 1.26? Okay, 1.26. There's your two x-intercepts right there. Got it? Okay. It just means there's two answers. That's what I was showing right here. One of your answers is going to be 5 plus the square root of 14, 5 minus the square root of 14. This is why you use it. Let me show you. Let's show you guys why this works. Let's say I have x squared equals 4. What number can I put in for x and make that true? 2. Or negative 2, right? So if I was to take the square root of both sides, square root of x squared is x. The square root of 4 is 2, but I know that there's actually two numbers at work. The positive 2 or negative 2 works, right? So it's actually plus or minus 2. There's two answers. And so anytime you take the square root of x squared on one side, the other side is going to be positive and negative. Got it? So that's why it's always going to be that way. Branson. It's going to be that number minus 2? Yeah, exactly. You're right. Well, every problem is going to be different. This is just, that's true for this one because you got to minus the 2. Say that again? Why didn't the front of what change? Huh? Well, it gave us two different problems. Like in C it says replace f of x with 0, and in D it says replace f of x with 16. Does that make sense? That's why we changed the front of it. Is that what you mean? Okay. So do you guys, after doing a problem like 11, you understand how to do it that way? Now, here's the only difference, you guys. Look at number 10. Everybody go to number 10. I want you to listen to this. On number 10, it's in standard form. You got two choices. You can complete the square on it and put it in vertex form if you want. And then you can solve it like we did number 11. Or when you get to C and D, you can use the quadratic formula to do them. Okay? So what we did for our bell work today. Okay, so watch. Let's do number 10. Everybody, do you guys want to do 10 or 12? Actually, 12's way easy. 10, well, actually, 12 is a perfect square trinomial, so it's really easy. Okay, number 10, you guys. Hey, some of you guys are getting caught up on problems. You guys, 10 through 15. I want all eyes right here because we've done, in this class, we have done so many problems just like this, and some of you guys still don't know what this means. You don't know what the notation means. Okay? Like on the one we just did. What number was that? 11. You guys, when it tells us to find g of 0, that means 0 is going in for x, right? All we did is replace x 0. Same with g of 5. Put 5 in for x. Do you understand that part? That's the notation there. But when it says g of x equals 0, or g of x equals 16, like these two, you're replacing this g of x with 0 or 16, okay? And then you're solving the equation. Which one's easier to do? When they give us g of 0 and g of 5? Or g of x equals 0 and g of x equals 16? The first two or the last two? First two are a lot easier, right? Because you're just putting 0 in for, or you're putting a number in for x and evaluating it. The second two, you actually have to solve an equation. It's a little bit more difficult. But it's, you guys, this stuff is easy stuff once you've practiced it enough. We just got to practice it enough. Okay, so going back to 10. I'm going to do 10 really quickly. F of x equals x squared plus 4x minus 12. I think you guys all know how to find f of 0. What am I going to do to find f of 0? Put 0 in for x, just evaluate it. Now it's going to be easy because that's going to be 0, that's going to be 0. That's, the answer is what? Negative 12, okay? Now I got to put in f of 20. No, f of 2. Sticking up the wrong part. F of 2. What does that mean? 2 squared plus 4 times 2 minus 12. 2 squared is 4. 4 times 2 is 8. 4 plus 8 is 12. 12 minus 12 is 0. Okay? So in other words, what's one of your x-intercepts? Shows you which one of your x-intercepts is. No. What? Your y-intercept is 0, comma, negative 12. This is a y-intercept right here. Because x is 0, y is negative 12. That's your x-intercept. This right here, you guys, 2 comma 0 is an x-intercept. Because if y is 0, which we just got, we got y is 0, that means 2 is a x-intercept. So guess what? When you guys go down to part C, and it says f of x equals 0, we already got one of them. One of them's 2. But we're going to solve it. All we have to do is replace f of x with 0. So we have 0 equals x squared plus 4x minus 12. By the way, you can do this by factoring. We've learned how to do it by factoring, haven't we? We can put it in factored form. Does that one factor? What two numbers can you times together and get negative 12 and add together and get 4? 6 and negative 2. So x plus 6, x minus 2 equals 0. What number would you put in for x and add 6 and get 0? So one of your answers is negative 6. And right here, what number can I put in for x minus 2 and get 0? So x equals 2. We already knew that 2 is one of your x-intercepts. Negative 6 is the other one, right? X-intercepts is when y equals 0. Your last one, f of x equals 20. No, you got to put 20 equals x squared plus 4x minus 12. Is that what the equation was? Because this is not 0 this time. You can't do it by factor. You got to set it equal to 0 first. Do you guys all understand this? All eyes right here. Before you can solve a quadratic equation like this, you have to get it set equal to 0. So I'm going to have to minus 20 from both sides. I get x squared plus 4x minus 32 equals 0, right? Now you can check to see if it factors. Does it factor, or are we going to have to use the quadratic formula? What do you think? Good. X plus 8 and x minus 4 is factors, because 8 times negative 4 is negative 32, and 8 plus 4 is a positive 4, right? So you set each factor equal to 0. And so you get x equals negative 8 and x equals positive 4 are your two answers. Okay? That's how you do one like number 10. Now, this assignment's due when? I expect you to spend some time on it. I think some of you guys kind of got a little lazy over Thanksgiving. Didn't spend some time on your homework. The whole idea, too, is to take notes so you try to remember how to do these. Okay. Okay, if you go to number 1A, it gives you 3x plus 4y equals 12. Now, this is what you're supposed to do on this one. Grant, this is the first problem in your assignment. It says find the x-intercept of each equation below. Write your answer as an ordered pair. Consider how the format of the given equation either facilitates or inhibits your work. So, I just gave you the instructions. How do you find an x-intercept? Put 0 in for y. So we're going to go 3x plus 4 times 0 equals 12. 4 times 0 is 0, so I get 3x equals 12. How do I solve that? Divide by 3. I get x equals 4. It says write your answer as an ordered pair. What does that mean? 4 comma 0. That's how you write your answer. Because this is an ordered pair. It's a point on the graph. You go to 4 comma 0 and you put a point. Okay? Now, I'm not going to be able to answer the last part of that equation until we've done all of these. So this is what I want you to do. With your shoulder partner, I want you guys to take turns doing every other one. And then when the other person's done, this is how I want to do it. Okay? So Chaden is going to do it and explain to Noah while he does it what he's doing. Okay? And Noah, after we're all done, Noah's going to write it down on his paper. And then Noah's going to explain the next one to Chaden. Okay? So you're teaching each other. I want you to do it like that for, I'm going to give you 2 minutes to get as far as you can on those 6 problems. Okay, so we found out that ax plus by equals c is probably the easiest format for linear equations. Sit down, please. Okay, the easiest format. That's what I write down for problem number 2. Now, part 3. You're supposed to find the y-intercepts. How many of you have done those already? You guys gotten that far? Okay, same idea. Okay, turn it over to the back. I think the answer to number 4 is probably similar to the answer to number 2, isn't it? Yeah. Okay, you guys on problem number 5, it says for each of the given quadratic equations, describe the rectangle the equation fits with. What constraints have been placed on the dimensions of the rectangle? So I want you to look at number 5. Okay, number 5 gives me x squared plus 7x minus 170 equals 0. Now, in this problem right here, I'm supposed to find the rectangle that fits with this. In other words, I need to find a rectangle that's something like that. In other words, I'm supposed to do what with this? See if it does what? Factor. Okay? Now, right off the bat, I can see 2 numbers that you can times together and get 170, right? 10, well, I know that 10 times something is going to be 170 because it ends in 0. 10 times 17, as Alex is saying, right? Now, the difference between 10 and 17, since this is a negative, one's going to be positive, one's going to be negative. When I add them together, I can get a positive 7 doing that, right? If I make it x plus 17 times x minus 10, right? Because 17 times negative 10 is negative 170, and 17 plus negative 10 is 7. So what are my 2 x-intercepts, you guys? Negative 17 and positive 10 are my 2 x-intercepts. Okay? So, and it says, describe the rectangle the equation fits with. Actually, I'm guessing it meant the answer would be yeah, x plus 17 and x minus 10 is what it's looking for. Okay? That's what it's looking for. Because the 2 factors are what it's looking for. Do you understand that part? Now, I'll give you a hint. Out of those problems, 5, 6, 7, and 8, one of them doesn't factor. So what do you have to use? You have to use a quadratic formula. Okay? Everybody look at 9, 10, 11, and 12. Oh, by the way, you guys, on 5, 6, 7, and 8, all you had to do is go to this point right here. On problems 9, 10, 11, 12, you'll notice that they're same problems. That's when you go to this far and you find the answer. So if you do 5 through 8, you've got 9 through 12 as well. Okay? Now, on problems 13 through 21, it says write each expression below in factored form. All you have to do is factor all those. Okay? Now remember, we've done factoring before, haven't we? So why do they keep coming back to stuff like that? Supposed to build on stuff, and you're supposed to come back and review. So we're reviewing some problems that we've done already. So you got to do those by factoring. Now, so you should know how to do all of this assignment. Okay? Now, when is this assignment due? Monday, next week. Because remember, I always give you 2 classes to do it. Which assignment's due next time? 3.5 is due next time, okay? 3.4 was due today. Okay, I always give you 2 classes, but you always have 2 assignments out at a time. So I would suggest when you're doing these, I would suggest that you work and get as much done as you can so you know which questions to ask me next time you come to class. Some of you guys looked a little surprised today when I asked for 3.4. Okay, I expect it to be ready next time. 3.5, I'm not going to answer any questions on it. I just expect you to turn it in. If you need help, come see me before or after school.